Okay, now we're going to do the next part of H9E.1. We just talked about reflection and stretches and what else? And we just talked about enlargement. And so now we're going to talk about rotations and reflection on a line. So, um, so far we've been talking about, we've got our transformation matrix. I'm going to make this big. And then we've got our image matrix. And we've got our result matrix. Okay, and what we've been doing so far to make life easier is if our image matrix is 1, 0, 0, 1, then we know that the transfer matrix is going to be our result. So that's why we've been using 1, 0, 0, 1. So the first thing I'm going to do is I'm going to do the point 1, 0. And so 1, 0 is right there. Okay, this is 1, 0. Okay, and we want to rotate that point to this dot right there. So we can call that A prime. We want it to go there. And so we learned from our unit circle, if I can get it from my binder over here, that what we learned was the x-coordinate is cosine theta, and the y coordinate is sine theta. You might recall that if I've got here, this is going to be cosine theta, comma sine theta. We did that earlier in this course. Okay, so this new point here, we want it, if it's being rotated, I'm going to call that cosine theta, comma sine theta. Okay, so the x value here is cosine theta, and the y value is sine theta. So this is this point is going to transform to this location. Okay, now this point here, 0, 1, that is going to translate to here. Let's call that B prime. Okay, so so what is this new coordinate? So in the x direction, it looks like it's about this direction here, right? So this length here. The length from here to here, it looks like the same length to here. So it's this length here is sine theta. So I'm just going to call that sine theta. But it's going in the negative direction, so I'm going to call that negative sine theta. Now, going up and down in the y value, this long length looks like this, doesn't it? So this distance from there to there is cosine theta. So we're going positive cosine theta. So we've got so in the x value, I've got negative sine theta and cosine theta. So anyways, I'm just showing you how to get this transformation matrix. You don't actually, this is important for you to see where it comes from. And notice, dun, da, 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 they gave it to you right here. So I'm just showing you where these values come from with this. Okay, so all right, what will the matrix for a counter for a clockwise rotation of the magnitude B. So instead of counterclockwise, which this was counterclockwise, to go clockwise, it's going to go this way instead, and this way instead. And we could go through a similar explanation, but it's going to be cosine theta negative sine theta, cosine theta. Right? If I've gone this way, it'd be the x direction is the same amount. Right? I've gone this length in the x direction. And in the y direction, instead of positive sine theta, we're going down to negative sine theta. Okay? Because this new point is down here. Let's call that double prime. Okay. Okay. Let's call that's A double prime. Okay. And then B double prime. So if I'm going from here over to here, this length from there to there is the same as this, which is sine theta, and then this height here is cosine theta. Okay, and once again, you don't need to memorize this. All of these are here on the formula sheet. Cosine theta, negative sine theta, cosine theta. You don't need to memorize that transformation matrix. Okay, hence write down the matrix that represents a rotation of 60 degrees clockwise. So if I'm going to rotate clockwise, I'm going to use this transformation matrix, cosine theta, negative sine theta, sine phi theta, cosine theta. Okay, and so if I'm going to go 60 degrees, let's plug in 60 degrees, cosine 60, negative sine 60, sine 60, cosine 60. And so I'm going to get out my calculator, because we're allowed to use it. And so okay, make sure you're in the right mode, degree mode. Okay, good. So cosine 60 gives me 0.5. Sine 60 gives me, and this is negative, right? So negative 0.866. Sine 60 is 0.866. And then cosine 60, we already know, is 0.5. Okay. Now, if I wanted to use my unit circle, 60 degrees, we know 60 degrees is right here, 1/2 and radical 3 over 2. So I could have written this as 1/2 negative radical 3 over 2, radical 3 over 2, 1/2. I could have written my matrix like that if they say exact. So depending, if you do this in college and you're in some intense engineering course, they might want this answer. In the IB Math Applications and Interpretation HL course, I think they're fine with the decimal here, unless they specifically or otherwise state exact. Okay, so that's rotation. Let's talk about reflection. Okay, so what we're going to do now is we're going to reflect on this line right here. Okay, and this is the line y equals mx, and slope as you know, slope equals rise over run, right? And you know tangent of an angle is tangent is opposite over adjacent, right? And so the opposite side is your rise, and the adjacent side is run. So it seems plausible that I could replace slope with tangent theta. So that's what they do right here. They've replaced slope m with tangent. Okay, they're calling it tangent alpha. Okay, so my equation of the line, y equals mx. And so when we're doing reflections, at least in this course, it's always going to be about the origin 0, 0. Okay, and so if we reflect it at this angle across this line, that's what we got. Okay, so we're calling this angle here angle alpha. Okay, so and the diagram below represents we've got the image 1, 0. This is 1, 0, and we've got the point 0, 1. Okay, and so if I'm just going to turn the paper like this, and so it might make it more easy to see, because if we're going to reflect across this orange line, I'm going to do my best to make a 90-degree angle. Does that look like a 90-degree angle? So this point right here, when it's reflected, it's going to be down here. I'm going to call that B prime, and I'm going to try to draw a perpendicular line. Just trust me that I am perfect at making 90-degree angles because I am so amazing. So, just kidding. Okay, so this point here, 1, 0, is going to be reflected over to this point. I'm going to call that A prime. Okay, so just so you can understand, we're trying to move this one to here, and we're going to try to move this one down to here. Okay, in order to do a reflection. So we're going to explain why the image of 1, 0 has this coordinates here. Okay, so to move from here to here, to explain this, so if this angle here is alpha, to move and reflect over here, I've got to go an additional angle alpha. Does that make sense? So if I'm going to reflect boom, boom, I've got this angle here and this angle here should be a reflection of each other, which is why we have this double angle to alpha. So if I'm over here, then the opposite here, and this angle, if I'm dealing with the opposite side, just like we did before, our opposite side is this is our y value, and our y value is going to be sine theta. And here, in this example, this is the adjacent side from an angle, and this here is going to be cosine theta. So just like in this example, I can represent this coordinate here as adjacent over hypotenuse, which is equal to cosine theta. And here, for the y value, we have opposite over the hypotenuse, which is sine theta. But instead of theta, in this example, it's 2 alpha. That's how we get cosine 2 alpha and sine 2 alpha. So we can say because angle AOC is 2 alpha, and the length of OA is equal to 1. Okay, you might want to hit pause if you need to write that down, or hit rewind to hear that again. So by finding OBC, O, where's B? BC. Okay, so finding OBC in terms of angle alpha, find the image of 0, 1 under this transformation. So 0, 1 is this dot right here, and the image is going to go over to here. So you might notice that this angle here and this angle here are the same. These are similar triangles, okay? And this angle here and this angle here are the same. We don't know that angle with the dash, and I'm not going to worry about it. So, so if I want to find out from this with representation to this angle, this is, I'm just going to call this 2 alpha. Okay, so this is opposite from there, right? So opposite, and this hypotenuse is equal to 1, right? So opposite over hypotenuse. So we're gonna. So if I'm dealing with, I gotta write SOHCAHTOA over here. If I'm dealing with opposite and hypotenuse, I'm going to say sine. So in my x direction, I'm going to say sine of 2 alpha is equal to opposite over hypotenuse. So we're going to call that's x over the hypotenuse, which is 1. Okay. So we know x is sine 2 alpha, and then for the y direction, this is adjacent, right? And so if I'm dealing with adjacent and hypotenuse, I'm going to say cosine. So we can say cosine 2 alpha, because that's this angle, is equal to adjacent. This adjacent side is y. From there to there is my y distance over the hypotenuse, which is a length of 1. So now I can write this coordinate as sine 2 alpha, comma, cosine alpha. Oh, but it's going down here, right? So in the y direction, instead of cosine alpha, I'm going to say negative. Okay. So so that's b to b prime. And so I've got my, let's highlight that in blue. This is the transformation of 0, 1, and sorry, this is the transformation of 1, 0, and this is the transformation of 0, 1. So if I want to verify that this is the result, then I can say, okay, so here's my transformation matrix, here's my image matrix of 1, 0, and 0, 1. So I've got coordinates 1, 0, that's going to be the original image, and the original image here is 0, 1, and my the 1, 0 is translated to cosine 2 alpha, sine 2 alpha, and 0, 1 is translated to sine 2 alpha and negative cosine 2 alpha. Oops, I should have put a 2 here. Oopsies. Okay. Okay. Okay, and that's what we just said here. It matches. And once again, you don't need to memorize that. It's right here in our formula sheet. When we do a reflection on the line y equals tangent theta x. I'm just going to say this is mx, right? Slope. Okay. And there's no plus b because when we're going to do reflection in this course, the reflection will always be from the origin. Okay. So by first finding alpha, determine the matrix of the reflection around this line. So we want to find the transformation in terms of this. So from this example here, they're saying tangent alpha equals square root of 3. So now we need to find alpha. So tangent is opposite over adjacent. And so to get radical 3, if I look at my unit circle, opposite over adjacent is going to be radical 3 over 2 divided by 1/2. So that's going to be 60 degrees. So alpha equals 60 degrees. Okay. So now if I want to find the reflection on this line, I'm going to use this transformation, but instead of writing alpha, we're going to substitute 60 degrees for alpha. So now I can rewrite this as cosine 120, sine 120, sine 120, and negative cosine 120. Okay, and if I go to my unit circle, cosine of 120 degrees is going to be negative 1/2. And sine of 120 degrees is going to be radical 3 over 2. Okay, radical 3 over 2. And this is going to be positive 1/2. Okay, so this is our transformation matrix for a reflection on y equals that number. Okay, so by considering the images 1, 0, and 0, 1, find the matrix for a one-way stretch for a parallel to the x-axis with a scale of k. So I'm just going to use my cheat sheet here, formula page. So parallel to the x-axis, I know how to read. So I'm going to use K001 for A, K001, and this gets us a stretch in the x-axis. Okay, and an enlargement by scale factor k. So using this, an enlargement by scale factor k is going to be K00k. K00k. Okay. Okay. All right. Let's do example 7. Okay, so we're going to do a rotation 45 degrees anti-clockwise over the origin, given that cosine 45 degrees and sine 45 degrees, oh, you can't see what I'm doing, is radical 1 over radical 2. Okay, so if I look at my formula sheet, a rotation anti-clockwise, rotation anti-clockwise is going to use this. Okay, cosine theta, negative sine theta, sine theta, cosine theta. So you might want to hit pause. I'm just going to, this is what I just copied from our formula packet. And so I'm going to replace theta with 45 degrees. And then and then once we've replaced theta with 45 degrees, I'm going to replace cosine 45 with 1 over radical 2. Replace this with 1 over radical 2. Replace this with 1 over radical 2. And replace this with 1 over radical 2. But since this is negative, I'm going to put a negative there. Okay, so now I have my transformation matrix. Okay, so if I multiply the image matrix and the transformation matrix, I will get my result matrix. So write down the matrix that represents the horizontal stretch at a scale factor of 2. So horizontal stretch means in the x direction, we're going to, if I've got x comma y, the new location is going to be kx comma y. And so to have this horizontal stretch, I'm going to have to go to here. Okay, and so from the formula packet, the horizontal stretch is K0, 0, 1. Okay. Okay, and since we're doing a scale factor of 2, that means K is equal to radical 2. Okay, so now we're going to do two transformations. We're going to start off with the image of 2 radical 3, and so we want to find the image of 2 radical 3. This is my image point. Okay, this is my image. Okay, that's my image, 2, 3. After a rotation of 45 degrees counterclockwise about the origin, and then followed by a horizontal stretch. So the first thing we have to do is we need to multiply the transformation of the rotation. So after a rotation, and then the horizontal stretch. So it says we want to find the image after the rotation, followed by the horizontal stretch. So this is the first transformation. And this is the second transformation. So rotation of this, that's the first transformation, and followed by the horizontal stretch. So, okay. So the first thing I do is after I multiply this transformation matrix times this image, I'm going to, here's the steps, I'm going to end up with negative radical 2, 1 over 2, negative 1 over radical 2, and 5 over radical 2. And then I need to multiply the second transformation times the result of this orange thing. So this orange bracket represents the first transformation times the image. Okay, so now I'm going to multiply the second transformation times the orange image. And then when I do that, I get my final image here. You might want to hit pause if you need to copy this down. Okay, question D says, write down a single transformation that represents the rotation about this, and then followed by the horizontal stretch. Okay, so what they're saying is I want to find a transformation matrix that represents this happening first and this one happening second. So if this is the first transformation, if it's the first transformation, it needs to be on the right side. And this is the second transformation. It needs to be on the left side when I multiply this to this. And as you recall from our earlier lesson, I can't have them switched. I can't have the orange one first and then the blue one, because I will get a different matrix. So if I have the orange matrix first and then the blue one, that's going to give me a different transformation. So we're not doing that. And so after I do that transformation, we end up with this. Okay, so I guess let's talk through the next one, and then I'll do the rest of it on a third. So example 8, find the 2 by 2 matrix that will transform point 2, 1 to 1, 4, and the point 1, -3 to the point 4, 9. Okay, this is a pretty important example. So we don't know what the transformation matrix is. We want to find the matrix that will transform this. So I'm going to call my transformation matrix A, B, C, D. I don't know what the values of A, B, C, D are. Okay, so I'm going to call X prime, Y prime the finalized value. I don't know what color to use. Let's use so this is my we're going to get 1 and 4. Okay, so we have our transformation matrix. Let's just use orange. So this is our transformation matrix, and we're going to start off with our image. I have no idea what color to use. So we're starting off with this point, and it's going to result in this. So from what we learned in an earlier lesson, I think H9C, I think it was, I could rewrite this as an equation. A times 2 and B times 1 is going to give me 1. And then if I have C times 2 plus D times 1, and that's going to give me 4. So now I've got one equation. Okay, and now we're going to work with this other point here. So we're going to start off with 1, 3. So this is the original image, right? These are the original image. This is the transformation image. And this is the result. So I've got my transformation times the image, and that gets me this result. Okay, so the result here is 4, 9. Okay, so if I've got the transformation times the image to get my result, I've got A times 1 plus B times -3, and that's going to equal 4. And then the next line is going to be C times 1 plus negative 3 times d, and that's going to be equal to 9. So now I've got these equations, and I'm just going to look at just the a's and b's row here. So if I take, let's take this row here, 2a plus b equals 1, and I'm going to take this row here, a plus negative 3b equals 4. I'm just going to take those, and so I've got 2a plus b equals 1, and a minus 3b equals 4, and I could put those into a matrix. So I'm going to take out the coefficients, the 2, the 1, and the negative 3. And then we've got AB, and then my constants coefficient is 1, 4, and I put this into my calculator. I take the inverse of the 2, 1, 1, negative 3, and times my constants matrix, and then I can figure out that A is equal to 1 and B is equal to negative 1. Now I can take my other matrix. I have no idea what colors are left. Let's use red. So I'm going to take the other matrix, 2c plus d equals 4, and c minus 3d equals 9. So taking 2c plus d equals 4 and c minus 3d equals 9, I'm taking those rows and I'm going to write this as our constant matrix of 2, 1, 1, negative 3. So that's my coefficient matrix. My constant matrix is C and D, and my other matrix here is the 4 and the 9. Okay, and then so to figure out C and D, I can take the inverse of 2, 1, 1, negative 3, and times 4, 9, and if I put that into my calculator, I end up with C equals 3 and D equals 2. Okay, so now, my transformation is 1, negative 1, 3, negative 2. You might want to hit pause, and good luck. I'll have a video part 3 in just a minute.